Hi, my name's Nate Fulmer, and I want to talk to you today about Phet Simulations Online. It's this great online program from the University of Colorado in Boulder to simulate different situations for physics, chemistry, biology, etc., and get the students sort of engaged in building intuition about these different topics and getting to play with it a little bit. So let's go ahead and head online. And as we get in here, we're going to go to phet.colorado.edu. And this page should open up, Phet Interactive Simulations. It's a great program. You can make donations here. It's a completely free program. So that's one of the great advantages of this. And even though it says sign in, register over here, you don't need to create an account or anything like that in order to get on. You just go, hit play, and have at it. So you can see the different topics that we have over here on the left. We got physics, biology, chemistry, etc., etc. So great for a lot of different classes. I'm going to open up physics. I'm a physics guy, so this is where I would head or send my students. And over to the right, we'll have a whole comprehensive list of all the different simulations that they have in alphabetical order. Or you can see that they will also organize it by topic. So I'm going to go to motion. And let's see what they got here. So this is all the simulations they have for motion. They got a whole bunch, really great stuff. We had normal modes, talk about gravity and orbits, some pretty good stuff. One of the things I really want to point out is you'll notice this little icon in the bottom right-hand corner of each of the simulations. That's going to represent how the particular simulation is going to run. It's either your options are essentially HTML5, Java, or Flash, respectively, which is important to make note of because depending on the platform you're using, some of them might not work. For example, if you're using Chromebooks, I use Chromebooks with my students, then Java is not going to work. It's not going to open. So it's definitely something you want to check for ahead of time. But what's nice is they're gradually transitioning all of their simulations over to HTML5, which will run on any platform. You don't need any plugins, you don't need anything fancy like that. It'll just, you can get on it, hit play, and then go. So let's go ahead and pick one out just to check out and see what's going on. Let's do projectile motion. This is one I did with my students. So you click on projectile motion, open this up, and just go ahead and hit play. So here you go. Here is the projectile motion simulation. You got a bunch of different options of stuff you can play with. You got the cannon over here, and you can drag it around to change its starting position, its initial position, or its initial position in the Y direction, its initial height. And then obviously also you can drag around and change the angle that it's going to fire your cannon at. You can also manually change it over here on the right side. You can change out the initial speed, the mass of the object that's going to get fired, and the diameter of the object that will be fired, which really only matters if you choose to include air resistance, which is an option. You can turn it on and off, change the drag coefficient, and things like that, which is handy. You can get the students sort of engaged in, okay, here's the ideal situation in a vacuum. Now, how does air resistance affect the situation? And that can be pretty cool. Also, you got a couple other objects in here. You got the tape measure. So if you want to just measure different heights or lengths or what have you, it's an option, and then drag this target around, try to get the target by changing around the specs and see, oh, can I get it to land right on target? So let's go ahead and pick something out. This is just appears for fun. You want to do a baseball, bowling ball. Let's do a Buick. That seems pretty good. And just hit fire. And there you go, it explodes on impact. Great. So this is also great for, all right, now I had it at 48.9. Maybe I want to make it an even 50. Is that going to change things? Probably not a whole lot. Yeah, a little bit. And is that going to be different than if I fire it at 20 degrees, for example? Oh, yeah, there you go. It didn't fire quite as far. Let's go ahead and increase this, do it back up to 18. Ah, see, and I include score. I made it on target, so told me that I scored. erase, go ahead and clear it out, and you can start over from scratch. So yeah, this is great if you want to compare angles. If I fired at 20 degrees, how does that change then if I fire it at 40 degrees? And they can kind of get a sense of the range that you have, and it'll give you up here, here's the range, here's where it landed, the height. We have a negative 1.2. You'll notice it leaves the barrel, comes out, and then lands a little bit below the horizontal, below the x-axis. Anyways, great for also opening up discussions about vector components. I want to talk about how does velocity in the x direction versus the y direction, is that going to affect the range, the overall height of the trajectory path, things like that. Really opens up great discussions and gets students sort of playing with it. It's fun. You watch the car explode. They tell you score. Different stuff like that. But really helps build an intuition. That's what I really like about it, is that they start to get a sense of, okay, this is how it works. This is what I can sort of expect to see. So Phet Simulations, they have a whole bunch of them. Really great program. Highly recommend it. And I hope you check it out. All right. Thank you very much.